Hello guys, welcome back to continue the solution for the revision for quiz 1, quarter 4. For question number 10, it is not like this question will not be included in this quiz because it talk about the absolute extrema. Okay, I will not solve it, but maybe I solve like this one later in the revision for the final exam. Here for this one, find all critical number for the function. This rational function, as you see, I'll show you how to solve it. Here, how to get the critical number? By find the first derivative. I'll try to solve in the empty space here. The first derivative here equal what? Use the quotient rule. But before I start, this function, its domain is what? The domain here, domain x not equal negative 3. It means all of the values of x except x equal negative 3, okay? It is not, the function is not defined at it, okay? Here I use what? The quotient rule. X plus 3 all to power 2 begin with x plus 3 multiply the derivative of numerator, which is 1, minus the numerator x minus 1 multiply the derivative of denominator, which is 1. I think it's so easy for you. Then simplify, it will be x plus 3 all to power 2. X plus 3 minus x plus 1. So this one cancel. It will be what? 4 over x plus 3 all to power 2. Here, as you see, the first derivative here, the first derivative equal what? 4 over x plus 3 all to power 2. The critical number at the values of x where the first derivative equals 0 or does not exist. Here, as you know, the function here, impossible. The first derivative to be 0 because it's in 0 if the numerator equals 0. Since the numerator positive, numerator equal number, so impossible the first derivative to be 0. And the denominator here undefined when x equal negative 3, but already the function undefined at it. Because the critical number, the function must be continuous at it. So, there is no critical number. That is why we choose E. None of these. None of these. I'll tell you why. Here, miss. The critical number of a given function must be continuous as the critical number. If the function does not continuous, okay, at a given value, impossible to be critical number. Here, x not equal negative 3, not included in the domain, okay? And as you see here, the first derivative impossible to be 0 because the numerator is a number, so I don't have any values of x at which the first derivative equal 0 or does not exist. That is why there is no critical number. Here, find all critical numbers for the function f(x) equal 9 minus x to power 2 all to power third. Okay, find the first derivative. How to find the first derivative? Sorry. Here, I'd like to have enough space for the answer. Maybe that is the last question. Here, find the first derivative. X, it will be, use the general power rule. General power rule, 3 over 5, multiply 9 minus x to power 2, decrease the exponent by 1. It will be negative 2 over 5. Multiply, don't forget, what inside? Negative 2x. Then rewrite the function to be in the simplest form. Here 3 and here what? 5. Which have negative power, it will be in the denominator 9 minus x to power 2 all to power 2/5. Which has no negative power, okay, 2x. Here, to find the critical number, the values at which the first derivative equals 0 or does not exist. Here, I have two cases, okay? F prime equal 0. When the numerator equals 0, it means negative 2, x equal what? 0, so x equal 0. That is the first critical number included in the domain? Yes. Because the domain here, all real number. Domain, all real number. Because the critical number must be included in the domain, or the function continuous at it, or defined at it. Okay? Here, f prime does not exist if the denominator here minus x to power 2, denominator equals 0. Implies x squared equal 9, implies x equal positive or negative what? 3. So what are the critical number? 0, 3, and negative 3. That is why your result, it will be. The problem here, because we have a negative power, you have to put it in the denominator. Or by another way, I find the zeros of the, if we have a product like this one, find the zeros of the factor which have a negative power or which has a positive power. You can say this one. Find the zeros of the factor, that is factor, okay? That is called factor, 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 which has a negative power, and the zeros of the which has no has positive power. I'm sorry. I hope you understand. Okay, I think we have finished all of the question, or we still have no. That's all. Look here. I'd like to tell you something. Here, critical number included because I needed all of these topic. Okay, here this one is not included. This that is why I don't solve this problem. Use the product rule U and V, okay, and apply the product rule. Equate each factor by 0. I think we finished all of the revision for the first quiz in quarter 4. Looks like the same idea will be included. Have a nice day. Thank you for joining the session. Bye-bye.